Hello everyone. In this video, we are going to learn Descartes rule of signs. This is a method to determine the maximum number of roots of an equation. Suppose an equation is given, then we have to find the maximum number of possible real roots of that equation. So let's begin. What does this rule tells about? This rule determines maximum number of possible positive or negative real roots of a polynomial equation. So here it is polynomial equation. It must be a polynomial. So this is true for a polynomial equation, first thing. And it determines the maximum number of positive and negative real roots. It tells about the real roots of the polynomial only. So what is the method? A method of determine, suppose this is the equation, we will talk about this. A method of determining the maximum number of positive and negative real roots of a polynomial. It is not a complete criterion. It means it cannot obtain the actual number of real roots, but it can predict the number of positive and negative real roots, because it does not provide the exact number of positive and negative real roots. The rule is applied by counting the number of signs in the sequence formed of the polynomial's coefficient. Suppose this is the polynomial. So we have to write the sign positive, 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 negative, negative. So this is the sign of the coefficients. So it is saying that the number of signs changes in the sequence formed by the polynomial's coefficients. So how many sign changes are there? There is only one sign change. If a coefficient is 0, then the term is simply omitted from the sequence. So here we can observe that here the term missing is x to the power 5, that is missing. So we have omitted the sign of x to the power 5 here. So first we have to arrange the variables in decreasing powers of x or increasing powers of x, and we have to write the sign of the coefficients, and we have to count the number of sign changes. So how we get the positive and negative real roots? The polynomial should be in a single variable, that should be in x or any other variable with real coefficients and ordered by decreasing variable exponents. That is the condition. Now see here, for positive real roots, it is the number of sign changes between the consecutive non-zero coefficients of fx equals to 0. Suppose fx is this one. So we write the sign. Here is only one sign change, positive to negative, only one sign change. So the equation has at most one positive real root. So this equation has, it means this equation has at most one positive real root. It means this can only have, if this equation has a real positive root, then that can be only one positive real root. I hope you get that point. Now negative real roots. It is the number of sign changes between the consecutive non-zero coefficients of f of minus x. It should be noted here, f of minus x. So first we write f of minus x. We change the sign here. So this becomes like this. So what will be the sign of the coefficients? Like this. There is only one sign change here also. Only one sign change. The equation has at most one negative real root. So this equation has at least 4 unreal roots. What we get the information? There can be only one negative real root and one positive real root. It means there are at least 4 real roots there are at least 4 roots which will be unreal. That is the confirm. And there can be more than 4 as well, because The positive one or the negative one can also be real. This is the maximum counting. Now come to the question. How many real solutions does this equation has? It is asking that. It is asked in JEE Mains. It is asked in JEE Mains. So how we find this? First we find for fx equals to 0, sign changes, positive, 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 negative. So there is only one sign change. Therefore maximum one positive real root. Suppose we write the sign changes for f of minus x. So this becomes minus x to the power 7 minus 7 x to the power 5 minus 8x cube minus 9x minus 10. Now write the sign changes. What will be the sign changes? Minus, 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 minus. No sign change. No sign change. Therefore, no negative real root. Since it is a polynomial of odd degree, since polynomial of odd degree, therefore it must have one real root. One real root. Since this is odd degree and it is saying that there is one positive real root, so it must have one real root, and that root is positive as well. That is positive real root. It means other 6 roots are unreal. Therefore other 6 roots are unreal. I hope you understand this. This is not very tough. This is very conceptual. So you can get this very easily. This is my notes. You can copy the concepts as such in your copy. Definitely this will benefit you a lot. Thanks.